thank you for having me, for the invitation, from the sponsors of this. And obviously it's important enough and a big enough honor for me to have been invited that I'm willing to fly domestic American air carriers economy for the government to be here. Although, Brian, I have to be honest, the last time I gave a talk at something Brian invited me to, I showed up with an upper respiratory tract infection. So now you invite me, I've got a bad knee. Small sample size, but getting way too reproducible. We gotta stop meeting like this. But I also want to, DoD, the Department of Defense, has an expression that amateurs talk about strategy, experts talk about logistics. So I can't see all the people in the back, and Whitney and Monica are doing an amazing job, but the logisticians here, I salute you, because you're making this happen. Okay, so if you looked at your agenda, you'll realize that I've changed the title of my talk. If you haven't realized it, what are you doing with your time? So I started with reproducible revolution. I changed that word to rigorous, and if I do this right in the talk, you'll understand why I did that, and we'll wrap this up in a beautiful narrative and story that'll propel you for years to come. You'll think back to this day. If that doesn't happen, I'll still try to explain why I did that. I've been always told that you want to get off the first slide as fast as possible, but this is Darpa, and we disrupt. So I'm going to spend a little bit of time here because I think it's really important. I am a social scientist, and sort of where you sit is where you stand. It's usually a figurative expression. So I'm going to give you some background on where I am and what DARPA sort of does and is about, because it's important. We sit in a really interesting area in the research field where we are both, I would say, the motivators for disruptive technology and science, but we are also very much consumers of the science. And that's why I'm particularly interested in being here, because the quality of that and the health of that ecosystem is really important for us. I also wanted to point out that we have this expression of casting a javelin into the spaces of the future. My name is actually Adam Russell. I couldn't put it on that slide or figure out how to do it so it didn't look like Adam Russell, javelin thrower. It just looked like that was a picture of me, and I can assure you that if I did throw javelins, I would put some knickers on first. All right. So, quick survey. Who's heard of DARPA? All right. Better than someplace I've been. Quick survey. Who currently or in the past has worked with DARPA? That is even more awesome. That's really encouraging. For those who didn't raise your hand, I'm coming for you. But it's important. So DARPA was founded in 1958 after the Soviets launched their satellite Sputnik, which was a technological surprise. I know there's debate in hindsight that, we should have seen it. But and since then, they've made these sort of, we use the term game-changing probably too casually sometimes, but legitimately game-changing investments in technologies. So like the internet, right? You're welcome. Sort of, maybe, right? This is TV. UAVs, global positioning systems, a host of different microelectronics, that's where we are, and that's where we are now looking about investing today for the next generation. But the reason I want to put this up here is that sentence at the bottom: these new capabilities require a healthy ecosystem across service S&T, universities, and industry, and that is absolutely true, because the health of that ecosystem determines the feedstock we bring in and what we're able then to transition or motivate in a wider community. DARPA is a place, we actually have a building, but we actually don't do any of the research ourselves. So we fund research, but we are not the active producers of that. And DARPA, actually a lot of people come to our office and really excited because of what DARPA does, and are deeply and quickly disappointed to find that the halls are not being roamed by robots, and that UAVs are not delivering coffee to us from the lower level. And our doors don't even go shh, in a sort of Star Trek way, which I'll keep working on that. But we are 6 smaller offices within DARPA and roughly 100 to 110 plus program managers at a given point. And those program managers are on very finite timelines. My badge comes with an expiration date, which is either, at that point I turn into spoiled milk or, very fine wine, depending on your metaphor. And that's important because that lends this sense of urgency to us. I only get so much of a time to throw a javelin and hopefully make a good dent in the universe. And in particular, I sit in the Defense Sciences Office, DSO. The reason I put this out, you'll figure out why I'm in DSO in a minute when I talk a little bit more about it. But DSO is also called DARPA's DARPA. And I'm really motivated to be here because DARPA, I'd say DSO, more than any other office, leverages basic research to try to take those really high-risk, high-payoff bets to see what we can get out of that. Okay, so we need you, other research communities, to do the work we do. I want to talk very briefly while I have the opportunity about how we do that, because again, sort of shapes my perspective on this. The first is the broad agency announcement. These are the project recalls you'll see come out, in which we have essentially specified via market research and other aspects, here's what we're trying to do, here's what we think the limitations are, here's why we're excited about the new opportunity, why we think we can make progress, here's how we're going to measure ourselves towards that progress, and here's the insanely ambitious schedule that you foolishly are going to sign up to try to do that. We have AI exploration push now, and that's really interesting because we can have a whole nother discussion some other time about reproducibility and artificial intelligence. That's going to be an interesting arm wrestle. But the goal is to get past what are called the first and second waves of AI. First waves being sort of encoding expert rules. Second wave being the large explosion of large data, largely statistically based approaches. The third wave, where we actually want to get after contextual reasoning and really counterfactual reasoning. This is really relevant, I hope, for this audience in particular. We have the Young Faculty Award process, where we identify up-and-comers and give them some money to do what they do really well, which is their research, but get them involved early on and potentially be a future performer as well as future program manager, because we need that. And then finally, the disruptioneering, real term, is meant to sort of do more crazy more quickly. So test out these ideas early on, pilot or exploratory research, but do so in a timeline between the solicitation and actually being on contract in 90 days, which if you've ever worked with the government before, that is hypersonic and doable. Okay, well, great. So you told us how to reach out or how we're coming for you. What do you care about? Well, DSO, we do the foundational investments, like I said, across things like frontiers in math, computation design, limits of sensing and sensors, and anticipating surprise, number of programs you can find on our website there. And then there's that one in the middle, complex social systems. And it's not uncommon to have people say, like, I'm sorry, I think there's a typo on your slide. What? It says social sciences. What's that doing at DARPA? All right, yeah. So enter social scientists, stage right. There have been an embarrassing dearth of Far Side cartoons. All right, we're going to address that over here. I'm not going to give you a whole lot of my origin story, partly because it's never the same thing twice, partly because it's probably inaccurate. But taking advantage of this internet we invented, we do actually have podcasts about our program managers. There's one called the Darpa Anthropologist. I did not come up with the term. If you're genuinely interested, mainly the question I get most often is like, DARPA's a widget shop, lots of physicists, engineers. What is it like to be the first, as far as we can tell, anthropologist, program manager, possibly the last in DARPA? And it is actually, in many cases, exactly like the XKCD cartoon, in which, yes, liberal arts majors are annoying, but nothing's as obnoxious as a physicist encountering a discipline or a topic for the first time. Just model as a simple system, come up with, include some variables you just thought of. Why do you need a journal anyway? So I'm used to people actually asking, I didn't know DARPA did the soft sciences. So let me tell you right now, I've made a habit now of saying, yes, you've heard from physics, material science, biology. Now let me tell you about the hardest science. That is in particular the human domain. So the military in many ways thinks about domains, maritime, air, sea, cyber. Across all of those things are the human domain. And the human domain is an area in which you, in order to operate, to be effective, you have to understand things like human social systems, variability, behavioral complexity. So as a result, and because I will not be at DARPA forever, I'm trying to come up with a way to convey succinctly and hopefully credibly to future physicists at DARPA why this is hard. And more importantly, why it may even be harder than what you guys are dealing with. And the best I've got right now, I'm open to suggestions. Please find me afterwards. Is the first that with humans, all agents are strategic, right? We even talk about this with our participants. I need your data for my paper. They're thinking, I need your extra credit so I can pass this course. Let the game begin. Effects become causes, right? And here, I'm actually talking about the collective fictions that humans in particular make that as far as we know, is unique to human social systems. So something like, for example, Metascience. In effect, as a result of lots of people getting together talking about it, we all believe in this thing. It's not a real thing, but now it's going to actually be a cause and change behavior. History is only of so much use with human systems. Games can be altered, and you did a great talk about the whole point we're here is because rules can change. Things that we have treated traditionally as immutable, biological, completely inflexible turn out not to be that case, and actually more often than not. And then finally, motivations change. So yesterday there was a question about the degree to which we have to depend upon the assumptions of rational actor theory to model sort of scientific behavior. That's a problem because we see people doing things, and sometimes it's for self-interested motives, sometimes it's for others, sometimes it's just what we do. As far as I know, physicists do not have that problem with electrons. So the end result, from where I sit, is that this interaction leads to a complexity in which we cannot reasonably use the simplifying assumptions that most of our theories and current tools require. We cannot reasonably model the world as mechanistic, timeless, universal. Boy, it'd be great if we could. We cannot reasonably aggregate humans, groups, or systems into a single representative agent. If you want to lose my interest at a cocktail party, come up and start talking about the human anything. Now, my last appeal to the physicists is, okay, don't believe me, believe one of you, right? Murray Gell-Mann said, imagine how much harder physics would be if electrons could think, to which I then dogpile with another physicist. Says, yeah, imagine how much harder physics would be if electrons could feel. Where are you going with this, Adam? All right, so the hardest science is hard, but does it have to be this hard? So this is my woe is me slide, right? We all have our woe is me's. Actually, more of woe is us, frankly. I want to talk about, in 2005, 2007, 2008, 2009, there was some early but seemingly credible research on oxytocin. It was so hot then. And really potentially very important at a basic research level, because that would allow us as a neurobiological mechanism or molecule to add an additional signal to try to understand this really important societal concept called trust and what kinds of trust we're dealing with, because we can't do that today. And so I had the good fortune of being a program manager at a different agency in which we were going to, among other signals, try to figure out, okay, if I trust you because you're competent or because you're benevolent or because you have high integrity, are those different kinds of constructs? Can we say something? We thought oxytocin might be able to help us do that. Well, we made the foolish decision of actually, let's first calibrate. Let's try to validate some of these associations that are being reported. We couldn't do it. Not only could we not do it, we couldn't talk about it. Not because we didn't want to, stop me if you heard this, because it took years to get a negative result published. Plus, I feel you. Finally put that out, and I, of course, was worried it's us, and it turns out it wasn't, because there's an increasing number of studies coming out saying, whoa, this is... in fact, one of the feedback we got from the original journal we submitted to, who had been part of this sort of generation, their comment was, yes, you've raised a deeply concerning point, but you haven't explained how the earlier authors got those results, so we're going to pass. We didn't, but I think other people are now starting to catch on how that might have happened. All right, so fast forward to 2017, oxytocin has been, as I like to say, Youngified. Ed Yong has come after it. That's usually the death knell for these kinds of mythologies. Bless Ed Yong. And then, of course, an enormous trial of actual application of oxytocin, finding lots of null results across lots of placebo. Okay, I know some of you are going to say, like, hey, Adam, we could have told you that 10 years ago. Sure, you could have, because when it comes to human social behavior, everything's obvious once you know the answer. I just wanted to keep reminding you of that. Okay, so I think about myself at Darpa as a social scientist, and then I'm trying to get up to Pastor's quadrant. Everybody's familiar with this, I'm sure. I want to go from tinkering, that's funny, to basic research, which is how this seems like it's real, up to, hey, this looks like it might be useful. And then if we're really lucky, we get all the way down to the bottom and say, hey, this actually works. The problem I'm facing is this is the actual landscape I'm looking at. A series of chutes and ladders where I think the basic research is going to get us there, and whoop, and there are many, many more chutes than ladders in my experience. I will not belabor this, especially with this crowd. It's been nice to see that we're all sort of talking the same way. I will point out, though, this is where, and Annette touched on it earlier, this is the slide that invites what I call the unilluminating appeal to skepticism, where I put up and people say, like, yeah, but how do you know you can trust the reliability of the research on the research reliability? Mind blown. And this pun has not yet been used at this conference, I think, but anything you can do, I can do meta. Even if none of these things are true, though, there's still other concerns about the health of the wider ecology, right? So Smaldino's work on the natural selection of bad science, lots of assumptions being made. I think Paul will be the first to admit there's some limitations, but I think it's credible in the sense of it identifies these really big problems we have. Okay, so replication to the rescue. What do we mean by replication? I'm going to see if I can actually remember these off the top of my head. So we have Ioannidis' latest, in which he talks about methods reproducibility, results reproducibility, and inferential reproducibility. Or we talk about Clemens, in which he talks about verification, replication, reanalysis, and extension. Or we talk about Chavez, in which he talks about replicate as a thing, then repeatability, then reproducibility. Or we talk about Lebel, in which now we're talking about exact replication, very near replication, far replication, very far replication. And this isn't even to touch on the most recent one from National Academies on reproducibility and replicability in science, which I actually think how they define those are quite useful, in spite of what on the surface appear, to me at least, to be a couple of bewildering claims about the tension between discovery and replicability. So let's get back to DARPA. So now I'm going to tie these things together and say, what does replication or reproducibility at Darpa look like? And I can't answer that. And I can't answer it, again, not because I'm not allowed to, but because every program that comes out of Darpa has to answer these questions, the Heilmeier catechisms. And so as a result, every program will look different, and every program manager will have a different take. But I think the purpose of this transformation function, the Heilmeier catechism, is to take replicability and reproducibility off the table and introduce rigor. What do I mean by rigor? I'm going to define rigor today, as far as I know, I hope accurately. Rigor is the willingness and the ability to legibly fail. What do I mean by legible failure? Boom. So legible failure. Public failure, willingness to fail. In fact, the importance is to fail. Because if you're willing to do that, you can do this. This is from a program called Haptics, in which they are now closing the loop between the ability to control a prosthetic, essentially using neural connections, and actually now to feel it back as well.
I could do this, it'd be a miracle.
She previously had a hook for her hand.
Yeah.
This is his fiance. He can now hold his fiance's hand. I don't know about you, but my 2005 self's oxytocin just went off the scales. So what does replication in the human domain mean, though, right? We're not building widgets. It's really hard, especially I'm going to talk briefly through some of the investments I've made and how they touch on replication and reproducibility, or at least how I've tried to make them too. Because when it comes to the human domain, it is not that DoD or national security decision makers are going to use social science. It's that they actually have to do social science, right? The world changes. We have new questions we've never seen before. And so how do I help us do social science? Well, the first program I'm going to talk about is next generation social science. And I'm not going to tell you all the details because it's available on the website, et cetera. But the challenge here was, how do we do experimental social science? How do we conduct the experiments ethically, practically, feasibly, at the scales we need to understand emergent behavior? The things we can't predict when we just do onesies or twosies or 10s or 12s, because that's the social behavior stuff. And so we've been investing in how do you automate as much of that process as possible across the workflow, the design of the experiments, the deployment of them, the capture of the data, the return, wrapping it up, and then making it and depositing it to be assessed as computationally reproducible. All the performers, this is the benefit of being a Darpa, all the performers therefore had to pre-register all of their studies. They are pre-registered. It's really interesting watching us break pre-registration when you start having highly multifactorial designs where there are lots of things going on. Great, good exercise, and that's on us. But they've also proved that all of them are computationally reproducible because they all had to reproduce each other's results. That was pretty compelling. Do they like doing that? Talk about this some other time. Then Ground Truth is a program we're running where we're trying to create what essentially are wind tunnels for social science and methodology. So here the question is less about the results being replicable, more about the methods that we use. So what you'll get here is the birth of a world. On one side, we are developing simulations that result in socially plausible, not realistic, but socially plausible complex data of the kinds you deal with in social science. So the question is, does your modeling method replicate across both different worlds or even in the same world given different starting conditions? Understanding group biases. So this is a fun one. This is disruptioneering, by the way, right? Do more crazy more quickly. The goal of this is to try to turn a bug of machine learning into a feature. So we all know, or we should, and if you don't know, you should know now, that algorithms that are developed and trained against large data sets tend to pick up the implicit biases that are in those data sets. And that is a really bad thing. It's a really bad thing if you want to do something like make recommendations for parole or selection and assessment. However, if we think about how we could use that as a mirror on ourselves or even other people, that could be really helpful in understanding how people see the world, perhaps in ways they don't even fully appreciate. I'm an anthropologist, I'm interested in cultural models. So the question is, can we use that bug and turn it into a feature so that we can actually figure out implicit biases and get a better sense of how people see the world in ways that perhaps they don't even appreciate it. This is also the program in which we blew up registered reports. God bless Chris Chambers. We worked as hard as we could to get it, but nobody knows how to put an approach that's going to require lots of different kinds of data and essentially a 300-dimension word indexing vector to say like, oh yeah, we're willing to sign off on that and publish what you get. So we also ran out of time because DARPA moves fast and the registered reports process, wasn't quite as accelerated. But we did see in action was this Repro Rubric that we developed for NGS2, where the performers now can score themselves, or we can score them, on how computationally reproducible are their materials. And the goal is to go all the way from the current state, which is kind of like, hey, I told you what you did, good luck, Tim, all the way to the top 5, where it's almost automatically reproducible in the work, that Annette's done very well. And then the SCORE program, again, this is sort of me going meta. The SCORE program is looking to see whether or not we can develop tools, ideally automated tools in the future, to assign confidence scores to published literature as it comes on, particularly in social behavioral sciences, so that if I'm a decision maker or I have to make some terrible decisions about where I'm going to send young people to help try to stabilize society, or these important questions that come along in the human domain, how much confidence should I have in these results? Could I have used this in 2005 to figure out quickly? Nothing there. And in the process, we're both doing replications, and I swear, Brian, I'm not trying to kill your team. We're doing replications at a new scale, a new speed, but also learning a lot about replications itself. So I consider this a huge privilege to have the opportunity to build out this portfolio and keep driving this direction. And I say we need to keep driving this direction because while I'm here, I'm still trying to push social behavioral sciences towards rigor. Not necessarily reproducibility, that may be necessary but not sufficient rigor to answer and solve problems, in particular focusing on things like triangulation. Run the experiments you can run. Give me the modeling and simulation approaches that you think are, the theories should predict you'll see. Give me the case studies that are actually, observed in the real world, and bring those together. I'm actually sort of proud to say that this week's cover of Nature is in fact an NGS2 performer who did exactly this, the triangulation. And I'm even more proud to say all of that research was pre-registered and is fully reproducible. The data, the code are available if anybody wants to go after it. In fact, please do, because if it's not reproducible, you know who to talk to. We're still looking for Goldilocks problems. And so this is the hard part in where I live, is what is the problem that we can put forward to motivate this kind of advance? I know I need a two-way prosthetic. What do I actually need to deal with in the human domain? And more particularly, how do I set up a problem that's like not too hard, solve global instability, and not too trivial? Enhance click-through by 0.5%. So what is that middle spot, right? Where it's clearly important, it's clearly hard, but it's also measurable. And I'm also trying to instill in my researchers, particularly, and hopefully wider community, this designer mindset. To get past this idea of, yes, you've got a positive result, you are finished, but all you have done essentially is either conjectured or prototyped. Now we need to test that, and we need to close the abductive loop. There is no optimal in the human domain. There are many ways to go after solving these problems. We need a mindset of this is just part of it. So I'm really concerned, as I said earlier, about the conjecture capability, because if I rely on my own research, I will get exactly what I've done. And that actually has historically been, in many ways the case. But with all the awesome, technologies and insights that are coming out of this conference, for example, that conjecture is going to be even more important, in some cases, potentially more inscrutable. So it's really important for me to do this. So my time at DARPA is growing short, as is my time on the stage. Being a DARPA program manager, how do I hurry this up? Well, I am aware of the risks of shortcuts. That's actually not how I did my leg either. It's not very. So this is my chance to end by casting the javelin. into the endless spaces of the future and probably end up hitting someone. I apologize in advance, heads up, but also to stimulate some discussion here in a way that kind of I think DARPA gives me license to do. So based on my experience, both in funding research, but also having to lever research, I think it's fair to say right now that replication is currently really slow, 6 years in some cases. Currently late. I wanted to say too late, but that's not always true, but in many cases it is. It's unpopular. It's really unpopular with the performers. They didn't love having to do it. They want to go off on their novel results and get going. It's unpopular with funders to a degree because, hey, look, we funded a replication. That takes brave people to do that. And obviously it's unpopular with the journals. It's considered distracting by many. Okay, look, why are we doing this? We could be over here doing this other cool thing. It's oftentimes narrow. So the replication you can actually do is oftentimes very, very focused on a very specific area that if you think about that abductive loop is a small cog in the much larger question. It's really hard. Witness Tim, for example, yesterday's talk. It's not always informative. That's a real problem. As again, we saw yesterday that the confirmatory research didn't work, but the replications did. I'm not sure that's all that informative. And it's really resource intensive. Just ask me sometime about the SCORE budget. It is also critical. This is a dilly of a pickle. So let me throw my first javelin as a DARPA program manager and say, okay, here's option one. What if we made replication automatic? It just happened on its own. Now, I want you all to close your eyes because we're going to be sort of visionaries here, weird. Imagine a world and what that would look like as to what replication would be if it were automatic. I don't have the answer to that, but I am working on it, and we've had the good luck to work with really smart people, in part helped by the Center for Open Science, on thinking about the investments we can make to get there. So if we can make it automatic, then suddenly it's not slow, it's not late, it's not unpopular, it's not distracting, it's not narrow, it's not always, it may still not be informative, but we've got replication and ideally reduces the resource. What if we can't do that? Well, is there any way that we can make it not critical? Is there any way that we can make replication unnecessary? Again, I'll ask you to close your eyes because you're gonna look at this and just laugh, like this is ridiculous. But what would it take actually to put in place a science where replication became something those guys back in the early part of the 21st century had to do? It is ridiculous. So I'm going to appeal to Dater's second law, which, if you haven't heard of it, is any useful statement about the future should at first appear ridiculous. Now, I'm aware of the twisted logic there, which is not everything that's ridiculous is necessarily a useful statement about the future. But I'd like to float this, and I'd be very interested in hearing people's thoughts on this, obviously. Let me end, having had some leg problems before. I went to school at Oxford. I arrived and I fractured my tibia, so I spent 4 months in a cast in what was essentially 14th century infrastructure. And it wasn't going well, and my very English tutor one day looked at me and said, "Keep cheery." So I want to end on a keep cheery note. In 1969, a small school in UCLA, you may have heard of it, sent the very first message via the internet, the ARPANET at that point, to Stanford Research Institute. And that message was low, which sounds amazing, right? I mean, so poetic. Who knew these computer scientists could actually grasp the monumentalism of this moment, except it was supposed to be login and the system crashed. So that's what success really looks like, right? And I wish I could say we are on the left-hand side of that it's going to be this linear growth and this trajectory and vector. It's clearly not going to be that way. It's clearly going to be on the right. But to me, at least, based on the work I've done, the awesome people I've had a chance to do that work with, and the really exciting discussions I'm hearing here, I know we're on the right trajectory, and I know you're on it. Thank you. Are there any orthopedic surgeons in the office? No? I just thought, well, I'm out here. Okay, sure. I can't accept the dinners. I'm a government employee, so.
Hey, Russell. Gully Burns, the Chan Zuckerberg Initiative. I'm a scientific knowledge engineer. So I'm really interested in the crazy idea that you put up about replication being unnecessary. I can kind of just extrapolate a little bit and try and think how that might work. Mm-hmm. Are you thinking in terms of the downstream consequences of research? So if I show you a finding and the finding is potentially interesting, and there's a reason why it's interesting because downstream its implications are X, Y, and Z, then you know, if I'm smart, right, do I wholeheartedly believe the claim, the original claim? Probably not, because you invest time and effort in trying to investigate that. How would one kind of think about evaluating the trust that I would place in a specific claim in terms of downstream strategizing and trying to build things? Is that the framework that you're thinking of in terms of making replication unnecessary? Or do we need to think about, so instead of having one specific kind of data point that we trust wholeheartedly and based a thrust on, if we had better infrastructure, then perhaps we would be able to say, okay, the implications of this claim being made here is inconsistent with all of these other claims, and therefore it's less likely to be true. Or it's like, oh, okay, this is really this is a claim that is very consistent with the rest of them, and therefore it's probably boring. Or maybe it's disruptive, and it's just the claim being made here is so disruptive, it kind of turns the entire field on its head, and is therefore, just crazy enough to be true. And if it was true, it could produce a big impact. Is that the kind of way in which you're thinking about this in terms of conceptualizing how one would go about doing that, or am I off kilter and I don't get it? Yeah.
No, the good news is the Venn diagram of how I'm thinking about it is so large that I challenge you to come up with a way of thinking about it that wouldn't fit in there, because I don't have a specified idea of how to do this. If people do have the time, looking at the first one was a technical exchange in complex social systems, where you had different teams break up into how might we automate more of this process, particularly for the human domain. But a number of them did actually talk about the ability to sort of scale up and increase the trust we can have in sort of meta-analyses, so that we are able to do this sort of thing, right? That we're able to take results and tie them into sort of theoretical streams that help make more sense out of them. But so to be very clear, this is not a hill I'm going to die on. I have a number of test and evaluation teams who think I'm absolutely insane for even bringing it up. Of course, we're always going to need replication, and that's probably true. But what is the world in which suddenly we don't actually have to use maps, but we can rely on our phone to get us someplace? So that's what I'm asking here. So I'm wide open to the discussion. I think one way it would be interesting, I do have a seedling looking at how do we actually develop theoretical meta-analyses to help get after this and automate that process. Seedlings were meant to essentially not work, right? But if they do, they take us from disbelief to doubt. So if that comes through, now I'm at doubt and not just disbelief. But to be honest, I am at disbelief as well right now. So if you're going to devote any of your mental bandwidth to this, you the man. Thank you.
Hi, Alex Danvers, social psychologist at University of Arizona. I think that the framing of some things as being like failures in research is kind of one of the issues that got us into this.
Yeah.
In that, like, you can make these big risky statements. And I guess what I've been thinking about lately in terms of like the proper way to do the scientific method is very closely related to sort of this like strong inference idea by Platt, where you take two alternatives and you rule one out. And in that sense, there's never a failure. You're just kind of like narrowing down.
Yep.
And it seems to me like we already have a lot of people who are like, I want to take a moonshot and do something crazy that's going to make me famous. Why don't we have funders who are like, okay, I'm going to be the like counterbalance to that, who's going to make sure that we're also doing the slow, normal, incremental science that actually tends to underlie all those breakthroughs, right? That doesn't get the credit,
Yeah. Okay. I'm sorry if I. Well, let me take your first point on the failure thing. Yeah. No, I think we need to come up with a different term than null result and failure, because that's just that's never going to play well with the crowd. Although I'm the kind of guy who came to IARPA and then Darpa. It's like they're gonna pay me to fail. Take that, Dad. And also, with the programs I put in, I mean, we are very public with the failures. In fact, it's funny you mentioned Platt, because at the very beginning of the NGS2 program, it is, you are not here to defend your theory, and the minute I get a sense you are, you're out. You are here to be an adjudicator and potentially, a discoverer of how these things put together. Because, people get very married to this theory, and if I fail, oh my God, suddenly the power pose doesn't work. Sorry to bring up a sore spot. So I think that is a problem and probably a branding thing, but it does also require we're human too, and so the notion that I'm gonna stand up and say, yep, we failed, hurrah, and expect the same sort of laudations that you would get if you were successful, I think that's unrealistic, but it's really important. It depends I think on leadership, frankly, everything has come down to. So your second question, I'm a little concerned that I didn't mean to give the impression that like DARPA is the only agency sort of willing to take risks here. I think we are particularly good at it and are protected accordingly to do it because of our track record. But, I said very early on, I mean very seriously, there is significant and important, basic research being funded around the ecosystem, from the service labs to NSF, NIH, other areas, that I think are really good. And I think the discussion, much of the motivation of this going on are people like Skip Lupia and other folks who are really, really concerned about the health of basic research. And I'm just here to like dogpile. Yeah, does that answer your question? Or
Yeah,
not really?
I guess the one thing that I would push back, and then I'll let other people jump in, would be, if you're this like really dynamic thinker who is in the meta-science movement, who understands some of these issues, where I don't get the sense that like an average NSF or NIH review panel does, wouldn't it be better for the person who's like, I am really in the, like weeds of understanding the scientific process and the sort of like underlying political and structural issues, wouldn't it be better for that to be the person who comes in and says, okay, I'm not gonna fund the super risky thing. I'm gonna fund the thing that actually answers, does it work this way or does it work that way? And sometimes when you were talking, I thought, yeah, that's exactly what they're talking about. But sometimes when you're talking, I was like, but is it, So.
Duck and weave.
Yeah.
Yes. Okay. Let me just end on what will be a very unsatisfying answer, but I think you're thinking about it in really interesting ways. In important ways. I would simply say the traditional response of biology to the face of complexity is diversity, and so I think that is an important lesson. And so I think there's room for all those things. The question is, how are these pieces talking to each other, and are there these sort of like choke points or real points of failure that are holding us back from where we could be? That's I'll leave that to other people. Oh, next question over here.
Hi, Adam.
Hi, Paul.
I'm Paul Smaldino. I wrote the paper.
Two papers.
Yeah, no, thank you. But particularly the one where you said that you used to illustrate making replication unnecessary. First of all, I just want we don't say that in the paper.
Oh, you didn't read? I added that at the end. Okay.
Damn, I knew I shouldn't have signed that clause. So I have many thoughts that I don't want to dominate this too much. But first of all, I think the pitch that social science matters is more important than anywhere, more important here than anywhere, because we are all people, and science is a social and cultural process, as Jacob mentioned yesterday. And thinking about the processes that lead us to do one thing or another, and the incentives, not just the practices, but the structures and the incentives that reward or punish people for doing whatever lead to different kinds of outcomes. And if we're gonna, so the idea of getting rid of replication is, I think, absurd, because what we're trying to do in a large way is produce, knowledge and truth, find out true things about the world. So if I find out a true thing about the world, that should mean that you can also look and find that same true thing about the world. And if it can't, then we're all just posturing, right?
Is it yeah, that's the legible failure part.
Yeah.
Right? So,
Yeah. So there's, like the Royal Society has this motto, right? To take no one's word for it. And so that should be the motto of science, I think, right? It's, let's find out for ourselves, let's do this, let me show you how I did it, and openness and replicability and everything. But I think it gets back to what you're talking about at the first part, which is rigor, right? And figuring out how we build social and cultural and incentive structures that incentivize and reward people for rigor, for slow science, for a world where first-year grad students aren't expected to have 3 publications, but actually can just spend some time learning what they're actually interested in, right? I don't know how to do that with the fact that we're, that the world is collapsing and we're all struggling to keep afloat, right? And there's way more people who want these cool jobs that we have than there are jobs to be given. But I'm curious just what you think, like, that a really amazing organization with a lot of resources like DARPA can do to incentivize these things above and beyond what you're already talking about?
So I think that last sort of abductive loop, the designer mentality, I think is what you're touching on. I think is really important. We need to think about how we design these systems to both anticipate but also potentially leverage some of these emergent properties that come out of that. And it's not going to be as simple as utility maximization or something. Right, as you're aware, there's these other problems that are involved in that. But I think that's an important area to be in. Like how would, and maybe that's the answer to the second last question was, how do we design the ecosystem so that actually replication is not needed because the rigor across the scales is so high, right? Because we have automated as much as we can where it makes sense, and because we've created people who realize that legible failure / rigor is the stuff you get rewarded for. We know more from a truly legible fail. We know more about the world than we did by something that just passes that magical p-value threshold.
Yeah.
In my opinion. So I think it's the design mentality, but
so real quick,
Yeah.
So right now, it seems like replication is in part being used to illustrate how broken the system is. And, so maybe in the ideal world, replication would be used as sort of a natural course. Like, of course, we just have to make sure that, our method can get this totally robust result that we've all been able to get. Anyway.
No, I'm with you. Like I said, it's just a javelin. Yeah, that's good. Last one?
Hi there. My name is Eli. I'm a student at Stanford. Thanks for a great talk. My question, I think, is a corollary to the incentives question, which is, I think a lot of people in this room are responsible for pushing out research, and there's probably a broad consensus here amongst the people who produce research that it should be replicable. My question is with regards to the groups who are pulling on research, so DARPA, but also as we sit in Silicon Valley, the analog to DARPA in the private sector is venture capital. For the people who make the incentives, what do you think their responsibility is in demanding rigor and demanding reproducibility? And how have you seen these sorts of entities who are responsible for pulling on the research and placing the incentives bake in these concepts into what they do? Because certainly society would benefit greatly from the resolution of ambiguity rather than the confirmation of potentially false, potentially profitable ideas.
Yeah. Boy, I'd love to talk to you a little bit more about your thoughts on the Silicon Valley model, because I don't know that much about it, to be honest. I watch from the outside, and depending on who you talk to, it produces these amazing breakthroughs, or Theranos. So it's always time to kind of sort of figure out. So I don't know enough about that. I think it's an interesting question. It goes back actually ultimately to, we're going to need Paul to model all this stuff to figure out how the incentives play out. As I said earlier on with DARPA, it really does have to be sort of organizational specific, but I have had, and perhaps it's unfair because I've had this string of really good luck in terms of leadership. I've been at presentations where our failure to replicate some of the early studies I took were actually highlighted. Like, look what we did, in that sense. So that's embraced. And then I think also, the extent to which you can actually put Heilmeier questions in place or something like them that ensures that you can actually answer these questions to really intelligent, non-expert people who are willing to put those resources up based on that. And that's the rigor. And nowhere in the Heilmeier question do we have to ask Elise, what's our profitable return on investment there? It's more about, are we actually solving a problem? And perhaps that's what I'll end on at some point is, do we think hard enough? Maybe at the basic research level, this is sort of anathema or heresy, but do you think hard enough about that use-inspired basic research? And is there some way that we can make these problems easier to define without dumbing them down so that we know if we're making progress in solving a problem rather than just maybe producing more noise or signal, TBD. So I can only speak, like I said, where he stand from my experience. But the Heilmeier Catechism, it's a nightmare. Program managers wake up in cold sweats because we have to answer these in front of really smart people. But it's also an amazingly good intellectual exercise that both launches these programs and then I think helps you track them going forward. And again, DARPA is a sometimes treat. If you're looking for a 5-year unrestricted grant, that's not going to happen at DARPA. But we will reward failure, which I think is pretty unique and important, and maybe a model for. All right, awesome. Thank you all. Appreciate it.